The last problem here is something I really should have addressed in an earlier video. Basically, there's two different ways to look at these tests. I'm trying to boil things down to as easy as possible, so I'm trying to only show the one way that I would have wanted you to do on the paper test, which is to compare p-values. But another valid way to set these up is to create a region of rejection or a z-score beyond which you'll be able to reject the null. So in order to find those z-scores, I'm going to show you the process, and then I'm going to point you to specifically slide 10 in this presentation where all the possible values are listed. So really, this paragraph doesn't matter. In this case, it says, suppose you want to design a hypothesis test around the proportion of Netflix subscribers who also subscribe to Disney+. You want to compare the proportion to 0.25. For each of the following known alternative hypotheses, determine what z-score would begin your region of rejection at alpha equals 0.10. This is really the only thing that matters. If I know what my alpha is, doesn't matter what proportion I'm comparing to, could be a test of means, test of proportions, as long as it's that set alpha of 0.10, there's set left-sided and right-sided values for a less than alternative, a greater than alternative, and a not equal to alternative. To find those specific values, here's what we originally did. For the left-sided value, we assume that we have the normal curve. We want to have a region of rejection that represents 10% of that curve. Since this is a less than test, we want that alpha to be in the left side. We want the shaded area here to be 0.10. So in order to find where that's happening in our table, we're really looking up 0.1000 in the center of the table and tracing that back to a z-score. We'd be on the negative side, looking in the middle for 0.1000. As I go down the left side, I see at negative 1.2, I get to 0.1151, so negative 1.2 has gone too far. I go up, or go down that row, and I see that where it hops over is between negative 1.28 and negative 1.29. Really, negative 1.28 has a table entry of 0.1003. Negative 1.29 has a table entry of 0.0985. So the one that's closest to what I want, 0.1000, is a z-score of z equals negative 1.28. What that means is, when I'm looking for a left-sided and right-sided value that starts my region of rejection, on the left side, if z is less than negative 1.28, that's where we're going to reject. There is no right-sided region because it's a less than test. That's why we say none here. So essentially, if I ran the test statistic and I got something like z equals negative 1.4, I wouldn't need to find an associated probability. If I'd already set up this region of rejection, I could say negative 1.4 is to the left of negative 1.28, which would mean that this test tells me to reject the null. So again, this is an alternative way of looking at these hypothesis tests where I look at what the region of rejection as a z-score would be as opposed to the p-value comparison that I've been doing most of the time. If I look at the second, the right-sided example where I'm doing a greater than test, again, I draw my curve. In this case, I'd want there to be 0.10 in the right side, which means back to the end of the earth would be 1 minus 0.10 or 0.90. So really in my table, I'd be looking for 0.9000. When I go to the positive side, I read down the left until I get to row 1.3 where I see it's 0.9032. If I look above in the 1.2 row, I can see where it jumps over. It's 0.8997 at 1.28 and 0.9015 at 1.29. The one that's closest to 0.9000 is 0.8997. That's why this choice is 1.28. Really, I could have known that because it's a symmetric table, whatever the left-sided value is as a negative will be the right-sided value as a positive. So here the right-sided value is 1.28. Because it's a greater than test, there is no left-sided value. Finally, we're going to look at a not equal to test. In this case, when we have a not equal to test, if we have two sides to the test, then we originally had an alpha of 0.10. We're going to need to divide that by 2 to say that 0.05 is what's going to be in each of these two tails. If I want 0.05 in each tail, to find this one, I'm going to look up 0.0500. To find this one, I'm going to look up 0.9500. So in the center of the table, when I go to find 0.0500, I can see that it's happening in the negative 1.6 row between 0.0505 and 0.0495. Really, it's directly in between. That's why we're going to use the average of those two, negative 1.64 and negative 1.65, to get negative 1.645. I could go through the process of looking it up on the other side, but you know it's just going to give me the positive answer, positive 1.645. So here the left side is negative 1.645. The right side is positive 1.645. You could do out the same math using the table in order to get the answers for alpha equals 0.05 and alpha equals 0.01. Or you could just look at slide number 10 of this PowerPoint presentation where it's listed for all three values of alpha what each of these answers would be.